Welcome to the first lesson on adding and subtracting simple rational expressions. In order to add or subtract rational expressions, we have to remember our fraction rules. That when we add or subtract, if we have a common denominator, we add across the numerator. So we would add 1 plus 3, and we keep that common denominator. When you subtract across the numerator. 4 minus 1, which of course would be 3. The denominator, we keep the same. So it's really important when we add or subtract fractions, or in this case, rational expressions, you must have or create a common denominator. For our first example, we have the quantity 4x divided by 4 plus a negative x over 4. Luckily, we have the same common denominator, so we can simply add the numerators. So that will give us 4x minus x all over that common denominator of 4. We're going to simplify the numerator, and we simply get 3x all over 4. In example 2, we have a quantity with a denominator of 8 minus another quantity divided by 8. So they have a common denominator, so we can simply go ahead and subtract. Now we have to be careful here. I'm going to put parentheses around these quantities of 5x minus 2 minus this quantity. So when we do our subtraction, we are going to have to distribute that negative. Think of that as a negative 1 since we're subtracting it. So I'm going to have 5x minus 2 minus here a negative 2x, which will give me a positive 2x, minus a negative 3, which gives me a positive 3, all over that denominator of 8. Let's combine like terms. I have a 5x and a 2x that will give me 7x. I have a negative 2 and a positive 3 that will give me plus 1 all over 8. And there's my answer. For example 3, I'm going to let you work it out first and give your answer as a quiz answer. So go ahead and stop the video. Alright, the solution. Since these are common denominators, I can simply add the numerators. So 2 plus a negative 7 is a negative 5 all over 7x squared. Another one for you to try on your own. Did you remember to distribute that negative, that subtraction sign? Therefore, your answer will be a 2x minus 7 all over 3x minus 7. Now, you may be thinking, hey, can I simplify that further? And the answer is no. I'm going to put these parentheses around these quantities once again. So you can see that they do not, the quantities do not simplify, do not cancel each other out. All right, so let's look at an example where we're adding or subtracting, and there's not a common denominator, and we have to find a common denominator. You want to think in terms of factors, things that multiply to give you these numbers. Well, the first denominator is a 3, meaning I have to have a factor of 3 for the first denominator. For the second denominator, it's a 7, meaning I have to have a factor of 7. Well, I don't already have a factor of 7 over here, so I have to add 1. Which means, if I multiply those together, our common denominator is going to be a 21. So I'm going to multiply the first quantity. I already have a denominator of 3, so I only have to multiply by a 7. So we're going to multiply by 7 over 7 times 5x over 3 minus, and I have my x over 7. Now here I have a denominator of 7, meaning I need to add a 3, a factor of 3. So I'm going to multiply by 3 over 3 So multiply across the numerators here. So 7 times 5 is 35x. I have my new denominator of 7 times 3, which is 21, minus x times 3 is 3x, all divided by 21. Now that I have a common denominator, I can go ahead and have that 35x minus a 3x, which will give me 32x over 21. Now if I could, I would simplify this fraction in front. 32 divided by 21, I don't believe that simplifies any further. So I'm finished. Let's look at another problem. Here we have two different denominators. One is a denominator of 6x. The other one is a denominator of 6. So let's again look at our factors to come up with a common denominator. On the first term, I have actually two factors, 6 times x. So I know I have to have a 6 and an x. In the second denominator, I have an x. Well, I already have an x over here, so that satisfies that. So my common denominator is going to be 6x. Since my first fraction, or rational expression, 1 over 6x, already has that common denominator, I can just leave that as 1 over 6x plus, then I have my 2 over x, and I need to multiply that by a factor of 6 in order to create that common denominator of 6x. And then I'm going to have 1, that's wrong pen, 1 over 6x plus 2 times 6 is 12, 12 over 6x. And since I have a common denominator, I can go ahead and simplify that. That's going to be 13 over 6x. And that is my final answer. Here is an example or a problem for you to try on your own. All right, here's the answer to example 7. Looking at your denominator, your lowest common denominator, well, I need a factor of 9 and x. For the second denominator, I need factors of 5 and x. I don't have a 5, so I need to add a 5. And I already have an x, so multiplying those together gives me a 45x for my common denominator. So multiply the first expression by 5 over 5, the second expression by 9 over 9. Do your multiplication, and then we have subtraction in this problem. Did you remember to subtract? And we get a negative 22 over 45x. All right, in example 8, we have denominators of 9x and 9x squared. So look at your first denominator, 9x, and we have two factors for our lowest common denominator. I'll get you used to seeing that LCD. So we have factors of 9 and x that we need for the first denominator. For the second denominator, I need a 9. Well, I already have a factor of 9. I need an x squared, or x times x. Well, I have one x, meaning I've got to add another x. So my lowest common denominator is going to be 9x squared. So let me bring down the problem here. And for the first term, I'm going to need to multiply by x over x in order to get a 9x squared in the denominator. The second expression, I already have a 9x squared in the denominator, so I don't need to multiply it by anything. So this is going to give me 7x over 9x squared plus 8 over 9x squared. I can go ahead and perform my addition. Now 7x plus 8, those are not like terms, so I'm simply going to write that as 7x plus 8 all over 9x squared. And there's my sum. The last example, which I believe, that example 9, is going to be left for you to go ahead and add this or find this sum and list your answer as the quiz answer.